here we are going to be talking about a reference angle. Now, what is a reference angle? There's many ways to describe what a reference angle is, but remember what we've been working with. We've been working with this terminal side and a line that goes from the terminal side to the x-axis, and it makes a triangle. So if we were to do that to all of these pictures, for instance, in this picture right here where it says quadrant 1, we can make a triangle out of that by drawing a line from the terminal side down to the x-axis. Look, we have a triangle. Same thing in quadrant 2. We're going to draw a line that goes down from the terminal side to the x-axis. Look, we have another triangle. Same thing with quadrant 3. We'll draw a line that goes from the terminal side to the x-axis right over there. And then quadrant 4 will be the same thing. Either way, we can make a triangle with our terminal side and the x-axis. Now, what does that have to do with reference angle? The reference angle is the angle that we can find inside of that triangle. Now, this is going to be different than the angle of the actual, angle that we're working with. This is going to be called the reference angle. And that's why we call it reference angle, because it's different than our full angle. So again, the reference angle is going to be the angle inside of that triangle that we've been making this whole time. Now, to find these reference angles, it's going to take a little bit of thinking about where something is. There's not going to be one specific way to be able to find this reference angle every single time. Now, I say that, but there are formulas right here that you can think about using. So, for instance, this first angle in quadrant 1, that's just going to be the regular angle, and the reference angle is going to be the same. So whenever you're in quadrant 1, you can just think of, oh, that's the same as the regular angle. Now let's look at quadrant 2. What is different about this? Well, if we have an angle that goes all the way to quadrant 2, our reference angle is going to be whatever finishes off that 180 degrees. That means if I have 180 degrees that I can show by this arc right here, and I go ahead and subtract the original angle, what am I left over with? I am left with the reference angle. So that means that if I take half the circle, or 180 degrees, what is that in radians? That is pi. Either way, if I subtract the angle, I will be left with the reference angle. Let's look at this one right over here. What is going on here? Well, let's think about this for a second. If I draw the entire angle, that will be represented by that arc. Now, what will I have to take away to leave only the reference angle? That's right. I would have to take away this 180 degrees. Once I take away the 180 degrees, I will be left with just the reference angle. If the angle is in quadrant 3, you're going to take the angle and then subtract 180 degrees, or pi if you're working with radians. Now this last one deals with the whole circle. It's not dealing with the half circles that we've been working with. So if I draw an angle that goes all the way around the circle, that's going to be 360 degrees. Now, the original angle is going from the initial side all the way around to the terminal side. So if I subtract that original angle, what am I left with? I am left with the reference angle. So to get the reference angle, if we're in quadrant 4, we're going to take 360 degrees, or 2 pi if we're working with radians, and subtract whatever the original angle was, and we would be left with the reference angle. So that's why I said there's no one way of doing this. You have to look at what angle that you are given and be able to apply the proper functions and subtract the proper thing to be able to find the reference angle. Let's try this out. So here it says sketch each angle, then find its reference angle. So the nice part is we've gone ahead and sketched this for you already. As you can see, 210 degrees lies in quadrant 3. So how can we find this reference angle? Now, one thing that we could do is that realize that it is in quadrant 3, go up to our thing, look at quadrant 3, and then apply the formula. But I like to understand what is actually happening with it. So if I have my full angle here, what can I erase to leave behind only my reference angle? Well, if I erase half of the circle, or 180 degrees, then that will leave me with whatever my reference angle is. So let's just do that. I'm going to have my original angle, which is 210 degrees, and I'm going to subtract half of the circle, which is going to be 180 degrees. And that should give me whatever my reference angle is. And that will equal 30 degrees. So my reference angle, which we show by theta and a little mark at the top right, is going to equal 30 degrees. Now here we have two things that you might be afraid of. First, we're working with radians, and second, we're working with a negative. So how can we get it if we're working with a negative radian? Well, first of all, we need to graph our angle. Now, there are many ways of graphing our angle. The first thing that we can do is convert it to degrees, graph it, and then convert it back into radians when we're done with the whole thing. But I'm going to show you my favorite way of graphing radians. And I think it is far easier than even graphing degrees. Please use the way that suits you best. But I want to show you something. I want you to think about when we say 5 pi over 4, what does that actually mean? Well, let's think about this for a second. What is pi over 4? You're taking pi and dividing it into 4 pieces. So if we look at pi, which is half a circle, and divide that into 4 pieces, what are we going to do? Well, this is going to be half a circle. It's already divided into 2 pieces. So if we divide both of those into 2 pieces as well, look at that. We have 4 pieces, which means that if we have a whole circle, that is also going to be divided into 4 pieces as well. So look at this. We have a circle that's divided into 8 pieces. We know that because pi is being divided into 4, or half the circle is being divided into 4. Now, what does 5 mean? Well, 5 means that you have 5 slices of this pi over 4 thing, and it's going in the negative direction. 1, 2, 3, 4, 5 of these things. Look at that. We have graphed our angle. Our initial side is going to be right here, and our terminal side is going to be along that pi over 4 line right over there. So that means, what is our reference angle? What is the angle that makes this triangle possible? Well, that's just going to be this guy right over there. What is that? We already know that is pi over 4. So we should be able to find out that our reference angle is going to equal pi over 4. Now, this is my favorite way of graphing radians, and I really implore you to really look into this method. But I'll also show you the other way that we can do this as well. The other way of doing this is to find a coterminal angle. So if we look at negative 5 pi over 4, we want the first positive coterminal angle. The way that we do that, if you look back at our video on how to find coterminal angles, you should be able to just keep on adding to pi until you find 3 pi over 4. You should be able to graph this just like we've done before, either by splitting pi up into 4 or converting it into degrees and then converting it back into radians once you're done. Either way, you should be able to come up with something that looks like this. Using our first positive coterminal angle, we should be able to find out that this is in quadrant number 2. We should be able to look up here and say, okay, this is going to be pi minus our theta. So down here, we're going to say pi minus our theta, which is now 3 pi over 4. And all we have to do is actually just type this into our calculator. Now here's the pro tip. You know that the ending answer will have pi on top of the fraction. So all you're going to do is just type in the actual numbers. This will be 1 pi over 1, so this will be 1 over 1 minus 3 over 4, and we're going to see what Desmos gives us for an answer. It gives us 0.25, but remember, we have to click this fractionator right over here and see that this gives us 1/4, which means that this will be 1 pi over 4, which was what we figured out before. 1 pi over 4, pi over 4, exact same thing. So this is our reference angle. It is guided practice time, so go ahead and try to figure this out for yourselves and start to play the video once you have done so. Thank you so much for pausing the video. I know you did because you're an amazing student. So first thing is first, we need to graph our angle. Now, instead of using negative 110, we're going to use our first positive coterminal angle. So let's add 360 degrees to 110.
It's 250.
So instead of working with negative 110, we will be working with positive 250. Now, where does that go? We know a couple things. We know that our up and down is going to be 90. This is going to be 180. This is going to be 270. So our terminal side will be somewhere down here, and our angle will look like this. So we need to find our reference angle. Our reference angle is going to be this angle right here. How do we find that? Well, if our angle is right here, how can we just get our reference angle? Well, all we would have to do is subtract the top part, which is 180 degrees. So let's do that. Let's use 250 minus 180 degrees.
It's 70.
So our reference angle is going to equal 70 degrees. Now let's give 3b a shot. First thing is first, you need to be able to graph your angle. Now you could convert this into degrees, graph it, and then convert it back into radians, but I'm going to do it the far superior way. If we have half a circle, or pi, and we look at 2 pi over 3, that is pi being divided into 3 different parts. Can I do that? Yes. I can make a line here and a line here. What does that do? That takes my half circle and divides it into 3 different parts. So what is my angle? Well, that's going to be 2 pi's over 3. So that's going to be 2 slices of this pi over 3. So my angle is going to look exactly like this. What is going to be my reference angle? Well, that's going to be whatever is between the terminal side and the x-axis right over there. We already know the size of that slice. That's going to be pi over 3. So we know that our terminal side, so we know that our reference angle is going to equal pi over 3. But even if we didn't know that, we still know that this is going to be in quadrant 2, which we can look back up over here and say, okay, quadrant 2 is just going to be pi minus our theta. So that means we would say pi minus 2 pi over 3. We would put 1 over 1 minus 2 over 3 into our calculator. We would find out that this is going to be 1 over 3, and then just pi goes on the top. So you can say 1 pi over 3, or just pi over 3.